Hello guys, so in our last video we talked about like anti-header and we get some data from file header and optional header. Today we're going to talk about section table and why we need section table while making an EDR or like antivirus. Because execution code means there is like entry point in that. In the last video we talked about it. Most of like legit binary have the entry point in the text section only. So if we found that some binary like the entry point is not in the text, that means it's like suspicious to us. And most of the section, like most, not like every section, like in the section table, is not writable by default. If we found any like section which is writable, and then means it's like modified and it could be suspicious or it will be like malicious, it should be like malware, because by default there's no writable bit in the section table. So before we start, this is our flow chart, and we will gonna start with this, and slowly we're gonna reach. Today's video can be lengthy, so have patience. I will drink some water while making this video. So what is image first section? So image first section is a macro, which is not official macro. What it does, it takes the anti-header. In short, it takes the anti-header and points out to the first section of the section table. For example, the first section of section table is like .text. That means it gives the pointer of that structure. So for structure, we have to see the structure of section header. So this is the structure of section header, and we can have see like names, physical address, virtual address, and so on. So first of all, we're gonna use we have to make a pointer to it, and we will gonna call it stack equal to, and now we're gonna use the pointer, sorry, a macro, and we will pass anti here, and now we have the first section of the section table. And here we also have the entry point. So what we're gonna do, we're gonna like check every section and find that like if there's like entry point which we already have. If we found what we say entry point in that section, then we will highlight it and we're gonna save bunch of things from there. So I will gonna save it some variable so that I don't have to write uh, let's call it like ep, and uh, pe info points to the, okay. So now we're gonna start a loop, and this loop will like run from like every section. So let's start like with int I equal to 0, and we will gonna compare it with number of section. It should be less than, it should be less than number of section, and we already have number of section here, but the data type it has u short, so we have to change like into u short here, and we have to pass info, and we have to increment I and increment sec. So what is it gonna do? It check the number of section, and we're gonna go from each section to another section and find the EP. So for finding the EP, we need some things like virtual address. So in this field, what is virtual address? Virtual address is like from where like code or data or anything get loaded into the memory. For example, there's a section called resources, and in the resources we have bunch of things which is required by the binary. For example, there's a GUI application, and it needs some images, so it will tell us that from here it get loaded. uh, like uh, let me start again. So for example, virtual address, from here the data has been loaded into the memory. And what we're gonna need also, like virtual size. Virtual size is like size of that data which is being loaded into the memory, simple as that. So if we have like virtual address which is started from here, and if we add here like virtual area plus virtual size, so we have the space in which we have to look EP into it. So if any of this place entry point is present, that means this section contains the entry point, simple as that. So that's what we're gonna do. So first of all, we're gonna save the like virtual address. So let's check the virtual address dword. So we have to use ulong. Let's call it start, and we will gonna say virtual address with set points to the virtual address. And now we have to need size ulong, and size equal to, now there is problem. Problem is that some of the malware, what they do, they make the virtual size equal to 0. In that case, the virtual address start from here. If we even add the virtual size, it will end here. So it will break our parsing system. So to fix this, what we can do. So there is another field here, size of raw data. Size of raw data, what it means, like size of the what we say section on the disk. So there's a difference between disk and memory. So when it get loaded into the what we say in memory, so it becomes virtual size, but on the disk it's like size of raw data. So if I say, if like virtual area is equal to 0, then we can use then we can make a virtual size is equal to row size, simple as that. And that's what we're gonna do. So we're gonna start with here, and there is another condition here, virtual size. So using that, there is, you can see something like this. What is this? This, assume this is like a container and only one thing we can put inside it. Either it can be like physical address, or it can be like virtual size. So physical address is like when some like binary get compiled, it says like I need like this location to execution. But memory is like shareable, so it's not like if like the section don't find that location, then we'll use virtual size and add the base size to it. For example, like a binary required 0x200 this location, and but it's not available right now, so it will use the virtual size. For example, the now it's getting this size 0, sorry, this location 30, and the virtual size what will do, and it will gonna load at this place 0x0040. So when we're gonna add this, and we will gonna find the location of the section which is loaded into the memory. So that's why how these things works. So what we're gonna do, we're gonna load this by using the table sec misc, and the field is virtual size. So there's another thing is collect and read rater. So how it works, like conditions, and if it's true then this value, if it's false then this value. So what we will gonna do, if this is not 0, then we will gonna take this value only, otherwise we will gonna use raw data, raw size data. So now we have the size and we have the start. So if I use a if condition and I say like if ep can be less than, if I go here, you can see like ep can start from here, so it can be like equal to it, and uh, less than it. So what we're gonna do, ep and greater than, sorry, it should be greater than, sorry, if I go here, it should be greater than virtual address or equal to it, and it should be less than virtual size, or this total, this combined. So what we gonna say here, as virtual, sorry, start, because we already saved, and we're gonna, and with both conditions should be true, ep should be less than uh, start plus size. So if this condition is true for like any section, we find like entry point. So what we're gonna do? So we're gonna need some things from there. We're gonna find that the section we found is like writable or executable. So there the things comes like characteristics here, and to use it we have to learn how it works. So basically it's 32-bit long, and from like its last four bytes, if I take 1111, so last byte like 31st byte shows say that it's readable, and 30th byte say it's writable, and 29th byte says it's executable. To check this, we're gonna use AND operator in bit mask. Let's go to image and we're gonna find this image. So in order to check which byte is doing which, like which byte is assigned to it, so if I want to check this byte is executable or not, so I will make it and with the only byte I have. So this will give me yes, this byte is executable because it will return in the end 0010. That's it. So that's how we're gonna use the condition here. So let's start, and we have to save this condition somewhere. So I'm gonna make another field boolean, and let's call it exec because we're gonna use to execute it, and uh, pe info save to exec equal to, so we're gonna go to the sec characteristics, and we're gonna make it and to the this byte, executable byte, and we make it like this, and we're gonna pass like it's true if it's not null, and it's false if it's returned. So we're gonna save this condition. So this condition, what is say, it will check the byte with the executable byte. If it returns like 1, then it's true. If it's like returns 0, then it's false. Simple as that. So same thing we can do with the writable part, and we're gonna copy and gonna paste, and let's write here write, and make another field write. So we have done the major task here. We found that EP, and we also found that the section is writable or executable. The last thing is left with we need to save the name of the section. So for that we have to check the name field here what it says. So basically it is like 8-bit long, so we have to make a buffer for ourselves. We gonna call it name, and we'll give the size of 9 because we have to add a null pointer after to it. So what we're gonna do, first of all we have to like make it empty so that we won't get any RTL 0 memory. Yes, so we're gonna use this function to make it 0. Everything should be removed. So this is like destination is PE info name, and size should be like length is size of PE info name, and we're going to use the same thing RTL copy memory. So we're going to use this function to copy the name into our buffer. So making mistake as usual, this should be PE. So this is the name we should use as a destination, and so should be is name, and length should be like a little bit I want to explain. Like we're going to use a condition minimum like 2 or 7. That means whoever the smallest will use that length, because in future if we change the buffer, or like if any position like if any bug can happen, like if the size of the buffer is changed. So I don't want that in future because it's hard to write code too long, and we're gonna write it 8, and for that size of PE info name and -1. That's it, and we're gonna have to add a null buffer also, PE info name to the 8th position because you start from 0, and we're gonna add null buffer 0. So we have done the most of the task here. So we already added what we say. Uh, we have the like name of the uh, uh, we have the name of the section, and we have the bit who tells us that like it's executable or writable, and I guess it's enough. If we want to, we can even check that we can even compare the string with the like txt that it's running in the PE we found it's in the text. So we can also do that. We can do by using str and compare. Here is it. So what we're gonna do, we're gonna start if condition. If I'm gonna take this and paste here, and string one, the string one is PE info, and this should points out to the name. Speed for second thing, next string is like .txt, and the length is 5. Should give us to the 00 because it's true. Then it should return true. What we're gonna say, we're gonna save another make another field here, and we're gonna call it take a data type boolean, and sec is text. That's it. We're gonna save it here, And what we're gonna do, we're gonna save it here. So RPE info points to sec is text equal to true. That's it. And now we're gonna log out things. Like now we're gonna print on debug view. So let's log, and first thing we can type the section, like section name, and we're gonna use string. So it's s. So executing bit, it should be uh, boolean, so it should be d, and writable, write again, it should be d. Now we have to pass the, so for string name there is a string name is saved in our structure. Second thing is info and write. That's it. And in last, we're gonna also log out. Uh, we're gonna use in our next condition when we make some rules. It doesn't matter if we log out it here. So let's check how many bugs we get. I think we're almost done. Anything red? Yes, something is red. Hmm. Long AP, we are saving image per section here. Okay, that's wrong. We have to save address point. Anything red? No, let's try building it, and we get some. Okay, the EDR is already running. We have to delete uh, stop norm, and we have to delete norm, and we have to create norm type kernel bin path, and we have to give the path. We have to first build it, and it's successfully loaded, and we have to start it. And let's see. And here you can see that we can see the section name is in text. And is it executable? Yes, but it's writable? No. So we like enhanced our EDR once again. And next in next video we're gonna write some rules which can stop the binary before executing. And in after that we're gonna focus on the main part, the recipe of the EDR is like data directives, from where we can see that which functions, which APIs, which DLLs is loading. So if you like this video, I humbly request you to please like this video, share this video, so that I will get more motivation to make these kinds of videos. Thank you guys for watching this video.